the shield that keeps us alive. Every moment of your life, an invisible shield protects you. Earth is not a passive world. It fights for every breath. Without this shield, solar storms and galactic radiation would tear at the atmosphere. Without it, life as we know it could not survive. Mars lost its magnetic shield billions of years ago. Today it is a dry, dead world. Earth still holds, but the shield is not invincible. It has weakened before. "42,000 years ago, the magnetic field faltered. Cosmic radiation surged into the atmosphere. Climate destabilized. Species vanished. Humanity was forced to adapt or die. Today, scientists are measuring another decline. Earth's shield is weakening again, quietly, steadily. The question is not whether collapse can happen. It already has. The real question is, are we prepared if it happens again? When the shield falls, what survives? The sun's breath, how solar magnetic fields shape life. The sun is not a static ball of fire. It is a living system, breathing plasma, twisting magnetic fields, and casting waves of charged particles into space. This solar wind, composed of ionized particles, fills the solar system. It forms the heliosphere, a giant magnetic shield that stretches far beyond Pluto. Beyond our sun lies the galaxy, filled with cosmic rays, particles moving near the speed of light, born in the depths of distant stars. The heliosphere acts as the first line of defense, slowing, deflecting, and scattering these deadly particles. But it is not perfect. Some cosmic rays penetrate deeper. Closer to home, Earth's magnetic field provides the second shield. Together, these forces create a fragile sanctuary, a place where life, water, and air can endure. The sun's magnetic field, and therefore the heliosphere, is not constant. It pulses through cycles. Approximately every 11 years, growing stronger, then weaker. During strong cycles, Earth's shields are battered but hold. During weak cycles, cosmic radiation can seep deeper, subtly, invisibly, but with profound biological consequences. Cosmic radiation can alter DNA. It can influence cloud formation, altering weather patterns. It can weaken Earth's atmosphere itself over long enough time spans. When the sun breathes strongly, life thrives. When the breath weakens, life must adapt or fall. What happens when the breath fails entirely? When the shield collapsed, the Laschamp event. Roughly 42,000 years ago, Earth's magnetic field weakened catastrophically. Known today as the Laschamp event, this was not a full magnetic reversal. But a dramatic collapse of the field's strength. During the peak of the event, Earth's magnetic field dropped to less than 10% of its normal strength. With the shield nearly gone, cosmic radiation flooded the atmosphere. Ionization rates surged, altering atmospheric chemistry, thinning the ozone layer, and exposing life directly to radiation. The climate destabilized. Glaciations expanded. Storm patterns shifted. Regional droughts and freezes rippled across the planet. Large animals, megafauna, suffered extinctions. Sensitive ecosystems collapsed. Genetic bottlenecks in many species suggest sharp population declines. Early Homo sapiens and other hominins faced the chaos head-on. They were forced to adapt rapidly, moving into caves, altering migration patterns, and evolving new survival strategies. It is no coincidence that some of the earliest known cave art, symbolic artifacts, and ritual behaviors appear during and immediately after the Laschamp event. The Laschamp event was not merely a shift of poles, it was a collapse of protection, a cosmic exposure, a survival crucible. The shields have failed before. They can fail again. The consequences of a broken sky. When Earth's magnetic shield collapses, the consequences ripple through every layer of life. High-energy cosmic rays bombard the atmosphere, triggering widespread ionization. The ozone layer, Earth's natural radiation shield, weakens. More ultraviolet radiation from the sun reaches the surface. Plants suffer DNA damage, crop yields collapse, food chains begin to fail. Ionization affects cloud nucleation. Storm systems grow more intense. Climate patterns fracture. Droughts, floods, and freezes strike in unpredictable waves. Human groups, dependent on seasonal stability for hunting and gathering, are forced into migration, shelter, or extinction. Radiation also reaches the genetic level. Increased mutation rates, both harmful and occasionally adaptive, ripple through life. Species that cannot adapt fast enough die. Those that survive carry the scars of the storm in their genomes. Even the sky changes. Auroras, once confined to the poles, sweep across latitudes, a visible sign of the broken shield above. When the shield falls, the storm is not only in the sky, it lives in the water, the air, the soil, and within the bodies of every surviving creature. 42,000 years ago, humanity faced the broken sky and adapted. Today, the sky weakens again. Survival under a broken sky. When Earth's shields fell 42,000 years ago, survival was no longer passive. It became an act of adaptation or extinction. Across continents, humans moved underground. Caves offered natural shielding, protecting against radiation, UV storms, and chaotic weather. Even a few meters of rock cuts radiation exposure by orders of magnitude. Caves were not just shelters. They became centers of culture, birthplaces of early symbolic art, ritual, and memory transmission. These markings, some dating directly to the time of geomagnetic collapse, suggest an urgent need to remember, to communicate across generations under the threat of annihilation. Migrations accelerated. Groups fractured and reformed, following shifting rain belts, surviving famine and flood. Technological innovations surged. Better clothing, refined tools, more sophisticated hunting strategies. The genetic record bears the scars. Bottlenecks, periods when humanity's numbers shrank to dangerous lows. Against a backdrop of cosmic storms, early humans endured. Not all survived, but those who did carried forward the memory, written in stone, in blood, in fire. They survived the collapse. But survival came at a cost. The Qualia Project. This research presentation is supported by the Qualia Project, an initiative dedicated to preserving critical memory, knowledge, and survival frameworks through periods of global change. Qualia. Preserve, adapt, survive. Memory is survival. The modern danger. The sun's shield is fading again. The events of 42,000 years ago are not ancient history alone. Today, scientists are measuring similar patterns, signs that Earth's cosmic shields are weakening once again. Since the late 20th century, the sun's magnetic field has shown a consistent, measurable weakening. Polar field strength during solar minima has declined sharply. The heliosphere, the vast magnetic bubble that protects the solar system, is contracting and becoming more porous. With less magnetic protection from the sun, cosmic ray levels inside the solar system have risen, reaching record highs during recent solar minima. Earth's own magnetic field is also weakening. In some regions, like the South Atlantic anomaly, satellites already suffer increased radiation exposure. The sun's activity cycles are becoming less vigorous. Fewer sunspots, weaker solar winds. A quieter, less protective sun. At high altitudes, pilots and passengers already receive increased radiation doses during flights, particularly near the poles where Earth's magnetic field offers the least protection. Weaker magnetic fields also leave critical infrastructure, power grids, satellites, communication systems, more vulnerable to solar storms and cosmic radiation. The signs are clear. Earth's shields are thinning. Cosmic exposure is rising. The shields are falling. Are we ready? What happens if it collapses again? If Earth's magnetic field and the sun's heliospheric shield collapse again, the consequences will not be theoretical. They will be immediate, global, and deadly. Without protection, cosmic rays and solar ultraviolet radiation will erode the ozone layer, allowing extreme ultraviolet exposure to reach the surface. UV radiation at lethal intensities would scorch ecosystems. Crops would fail. Surface life would be forced to retreat indoors, underground, or perish. Radiation would shatter DNA, leading to skyrocketing cancer rates, birth defects, and heritable mutations across generations. Atmospheric ionization would alter weather patterns. Droughts could become permanent. Storm systems could strengthen beyond historic norms. Satellites, navigation systems, and power grids, already fragile, would suffer widespread disruptions or total collapse. Aviation would change overnight. High-altitude flights would become dangerous or impossible. Space travel would require heavy shielding just to survive. Populations would shift violently, fleeing dead zones, collapsing infrastructure, failed harvests. Modern civilization, dependent on global communications, stable power, and high-yield agriculture, would face collapse risks unseen in recorded history. The sky would change first, haunting signs of the invisible storm raging beyond it. We survived once. But this time, we are not living in caves. Our response: preparation and resilience. The weakening of Earth's shields cannot be reversed by human hands. But survival is not passive. Satellite systems must be hardened, built with increased radiation tolerance. New orbits, emergency redundancies, and fail-safes are not optional. They are necessary. Critical infrastructure, power grids, communication networks, transportation hubs must be shielded against geomagnetic induction events and high-energy radiation storms. Food security will depend on controlled agriculture, underground farms, shielded greenhouses, resistant crop genetics. Medical science must prepare for increased mutation rates, cancer prevention, genetic repair technologies, radiation treatments adapted for mass civilian use. New architecture may evolve. Cities protected by engineered magnetic fields, deep earth facilities capable of sustaining large populations, environments designed to endure the slow storm. Resilience is not only technological, it is cultural. Future generations must remember why the sky matters, why Earth's invisible shields are not eternal. No single nation can face the collapse alone. International cooperation in heliophysics, disaster preparation, and survival planning must become a priority, not an afterthought. Survival is not guaranteed, but survival has always been a choice. To adapt, to prepare, to endure. The shield is not infinite, but memory can be. Memory and responsibility. Earth's magnetic shield is not eternal. The sun's protection is not permanent. The conditions that allowed humanity to thrive were never guaranteed. "42,000 years ago, humanity faced the collapse of the sky. They adapted. They remembered. Their survival became the foundation of everything we now take for granted. Today, we face the same forces, but with far more to lose. We know more. We can measure the weakening. We can predict the danger. But knowledge alone is not survival. Memory must be carried. Preparedness must be woven into the future, not just in technology, but in story, in teaching, in law. Our ancestors endured under a broken sky. If we forget what they faced, we risk losing what they saved. Small, fragile, still beautiful, still alive. The faint hum of cosmic radiation surrounds it. The shield will weaken. The storms will come. The question is not whether collapse will happen again. The question is, will we be ready, and will we remember? Preserve memory. Adapt. Endure. Qualia Project, our solar collapse had memory carriers.